tip of the rock basin, the rim, forms steep cliffs that tower above these three lakes. This immense wall of rock, called the Niagara Escarpment, forms the boundaries of these lakes and makes possible one of the world's greatest natural spectacles, Niagara Falls. Over this hard dolostone cliff, 3,000 tons of water a second tumble from 4 of the 5 lakes. But it's more than just a miracle of nature. Niagara Falls is a vital clue that helps scientists date when fresh water first began flowing into what we now call the Great Lakes. The Great Lakes of North America. Geologists have discovered 3 of the lakes were formed in a vast rock-lined basin laid down by an ancient lagoon. The question is when? And they think the answer lies here, Niagara Falls. Behind this curtain of water lies the evidence to when the lakes were made. Like the overflow from a bathtub, excess water from 4 of the 5 lakes, Superior, Michigan, Huron, and Erie, spills over the falls into Lake Ontario. And all that water is changing the falls, change that can be measured and used to calculate the age of the lakes themselves. The falls were first studied by one of modern geology's founding fathers, Charles Lyell. Lyell, who'd pioneered the early understanding of Earth's secrets, was intrigued by the concept of geological time.
Charles Lyell came to Niagara region in the 1840s, and he made very important observations at Niagara Falls. Lyell was using the principle that things that we see going on today can be used as examples for what went on in the past.
Lyell believed the world wasn't shaped in a few days or even years, but by slow change over millions and billions of years. This directly contradicted the much shorter time biblical scholars said the world had been in existence. Lyell realized that dramatic geological change was going on in front of his eyes at Niagara Falls. If he could measure it, he might be able to calculate the fall's age. Lyell's technique was brilliantly simple. He noticed below the falls was a great gorge, which locals said was steadily increasing in length as the water wore away the ledge of the falls. The falls, they said, were moving slowly upstream. Head to the base of the falls and you can see why. The cliff face is being worn away. The falls are formed by a cliff capped with a ledge of the same hard dolostone rock created, as we've seen, by seawater. Beneath the tough dolostone cap is a layer of much softer rock called shale.
As the water crashes over the dolostone, it erodes out these soft shales that are underlying the dolostone, and the blocks can fall down from the face. On the right, then, you can see these massive blocks of dolostone that have fallen down at the bottom of the waterfall.
Each time the dolostone ledge collapses, the falls move further upstream. Lyell believed this process had been going on for thousands of years and was still continuing. It had begun as the lakes were first formed when water began wearing away the hard dolostone ledge of the falls. To discover the age of the falls, all Charles Lyell needed was some simple math.
He realized that the falls had started at the Niagara Escarpment, which is about 35,000 feet from here. So if the falls receded at 1 foot per year and receded 35,000 feet, that would give an age for their present position of 35,000 years.
Lyell's calculation was based on simple measurements, but wrong guesswork. He thought the falls were receding by 1 foot a year. But today, we have much better records to go on.
This plaque commemorates Table Rock, which is where the falls were in the beginning of the 19th century. Since that time, they've receded about 600 feet to my right.
So in the last 200 years, the falls have steadily retreated at a rate of not 1 foot, but an astonishing 3 feet a year. So instead of Lyell's calculation of 35,000 years old, the Niagara Falls were a third of that figure, just 12,000 years old. A mere blink of an eye in Earth's 4.5 billion year history. In the search to find what created the Great Lakes, scientists now had a crucial clue: the age of one of their key features. Born at the same time, the falls is the overflow for all the upper lakes into Lake Ontario and the sea. So if the falls have only been around for 12,000 years, then it means the lakes themselves must also be incredibly young. Now that scientists had worked out when the lakes were created, the next question was, how? What immense force could have created not 1, but 5 huge lakes? Menzies decided to dig deeper, down to the landscape that existed before the ice ages. Going back 2.5 million years, he found evidence of a chain of ancient rivers flowing across what's now the Great Lakes region.
The pre-glacial topography of the Great Lakes Basin mirrors the existing Great Lakes system and Great Lakes basins that we see today.
The ancient river's pattern and flow exactly mirrored the shape and position of today's lakes. It's no coincidence. These rivers formed valleys that affected the way the ice sheets moved.
As the ice sheet advanced to the south, it would tend to follow the pre-glacial rivers, and so you get these really fast-moving zones of ice which create a tremendous amount of erosion in these pre-existing depressions.
The ancient river valleys funneled the ice sheets into fast-moving super ice flows. Menzies believes the coarse sediments the rivers left behind dramatically accelerated the ice sheet's flow.
This sediment acts as a kind of lubricant, a bit like ball bearings underneath the ice. It would actually speed it up quite appreciably.
These fast streams of super ice were even more destructive to the landscape. These ancient beaches, now buried under the surrounding landscape, are evidence of a colossal freshwater lake.
We're looking at a vast amount of water. When you think of the water, it stretched from here to beyond the present lake, way into New York State, beyond into Rochester, so it's a huge, enormous inland sea.
Despite their size, the Great Lakes today are just a small fraction of these vast prehistoric lakes. The water has vanished. Geologists want to know how they emptied. 50 miles east of Toronto, at India River Canyon, Menzies picks up the trail of the missing water torrents.
Okay, what we have here is an enormous subglacial pothole formed by subglacial meltwater exiting underneath the ice sheet, typically formed with a large roller ball which rolls around in these really torrential vortices. The meltwater is chock full of boulders and sediments, and in this instance it's drilled itself the whole way through.
These potholes are evidence of a catastrophic flood, of huge volumes of water moving at high speed. This flood needed an escape route, and Menzies believes he's found the place.
This would be an enormous torrent, possibly at least a couple of miles across, and could easily have been 200, 300, 400 feet deep, moving at an incredible velocity.
Nearby, a steep gorge, yet more evidence of the floodwater's terrifying power. The stream that remains today couldn't have cut such a huge amount of rock.
And what we've got left is what we call a misfit stream, which is the fairly small Indian River. And this, if you like, is the remnant of that enormous torrential flood.
Geologists believe as the ice sheet retreated, it uncovered this ancient India River outlet, allowing vast amounts of meltwater to tear down towards the sea. Finally, 12,000 years ago, the ice retreated, freeing the St. Lawrence Seaway and allowing the lakes to settle into their present flow. The story of the Great Lakes is coming together. Ice sheets repeatedly ground out deep basins, digging out ancient weaknesses in the Earth's crust. Prehistoric beaches show that when the final ice sheet melted, the water flooded the basin to create vast superlakes like Iroquois. And as the ice finally retreated 12,000 years ago, the excess water drained away to leave the Great Lakes we know today. But even now, as we know how the Great Lakes were formed, they are still changing. And scientists predict one day the lakes might disappear forever. The Great Lakes evolved over 1 billion years. Today, they're a vital link between the cities bordering the lakes and the sea. They provide over 20 million people with drinking water and irrigate crops throughout the Midwest. But in the past few years, fears have grown about the Great Lakes' future. Water levels are falling. People who have worked the lakes for years believe they can already see a change.
We noticed a drastic decrease in water levels right after the September long weekend, where the water in a week dropped a foot, and throughout the remaining of the fall, it went down about another 2 feet. And you can notice that by the pinker or the brighter colored rock versus the rock that's typically exposed to the weather. And what we saw there was a clear example of how the water has dropped a good 3 to 4 feet.
Many have been quick to blame global warming for the fall in lake levels. But geologists believe there is another force at work. The ice sheet that cut out the lakes was so heavy, it pushed down on the Earth's crust. Now the ice sheet has gone, the crust is bouncing back. Incredibly, 9,000 years since the end of the last ice age, the ground is still lifting. In the north, where the ice was thickest, land has risen by as much as 1,800 feet since the ice melted away. Toronto's famous CN Tower appears to be getting higher. As the crust bounces back, the land it's built on beside Lake Ontario rises nearly an inch each year.
The CN Tower is part of the landmass here, so in fact it's rising out of the land. In fact, the whole land surface is rising slowly.
Lake Nipissing today is a small body of water to the north of Lake Huron. 12,000 years ago, when the ice began to melt and Lake Nipissing first formed, it lay at sea level.
Lake Nipissing, an enormous lake there. Again, as the land rebounded, so the lake eventually drained out and the land rose slowly, so the land is now 400, 450 feet above sea level.
Geologists call this crustal rebound, and it dramatically affects the delicate balance of the network of small rivers that feed the lakes.
This is an interesting example. If we think of trying to explain crustal rebound, and we look at this river as it flows out into the lake at the moment, if we have crustal rebound, the land comes back up, this river in fact will cease flowing out into this lake.
It's this crustal rebound that's partly responsible for the fall in level of the lakes. And as the lakes empty, their weight decreases, allowing the crust to bounce up even faster.
Lake levels will fall, so the amount of water in the basin will in fact become less, and the effect of that will increase the rate of crustal rebound. The land will come up even faster than it's already doing and continues to do.
As the crust rises, the lakes slowly empty. But in a few thousand years, the lakes will face another, even more dramatic change.
One of the exciting things about geology these days is not only looking at the past, but is looking into the future. In other words, having the ability to start to predict what might happen in the next several millennia.
And the future is here at Niagara Falls, at least in geological terms. Every year, the falls are retreating 3 feet upriver. Only 12 miles and 21,000 years to go before they're back into Lake Erie. When that happens, everything will change, and fast.
If the falls eroded all the way back to Lake Erie, which would take some thousands of years, the levels of all the upper Great Lakes, Huron, Superior, and Michigan, would adjust to the lowered level of Lake Erie by dropping as well.
The land between the falls and the lakes acts as a block. It's the Niagara Escarpment, topped with hard dolostone rock. When the falls cuts its way through this rock, the water levels in all the lakes to the west would drop by a staggering 180 feet, the height of Niagara Falls. Almost all of Lake Erie would drain away. One day, the lakes may disappear altogether. But geologists also predict a new cycle of ice ages will begin again.
So an ice age would begin, and this ice age would then cover, we would expect, at least 30% of the land surface, as it did in the previous ice ages.
And when the ice returns, the lake basins will be cut even deeper before filling again with water. The largest freshwater lake system in the world has had an extraordinary past.